Today in Lecture 3, we will cover sections 2.6 through 2.7. At the end of today's lecture, you should be able to understand the underlying assumptions made when using both voltmeters and ammeters, as well as identify dependent sources and understand the four types of dependent sources: current-controlled voltage sources, voltage-controlled voltage sources, voltage-controlled current sources, and current-controlled current sources, and quantify their gain. To begin, we will talk about tools used to measure characteristics of our circuit elements. Oftentimes, we don't necessarily have to model the voltage potential across or the current running through an element. Rather, we can measure them directly using a voltmeter or ammeter. Oftentimes, a voltmeter and ammeter are one and the same, as shown in the picture below. This type of device is referred to as a multimeter. A multimeter allows you to measure voltage, resistance, as well as current, and oftentimes frequency, impedance, inductance, and the like. Now, the first component of a multimeter is the ammeter. An ammeter measures current running through an element. An ammeter is shown schematically below. The red lead is the positive terminal of our ammeter. The black lead is a negative terminal of our ammeter. In actuality, it does not matter which end you have connected, for you will get the same magnitude of the current running through your element. Now, one of the main assumptions with an ammeter is we assume its resistance is equal to 0, such that there is no voltage drop across our device. That is, with 0 resistance, the voltage potential across our positive and negative terminal would be 0. Now, as shown in our schematic above, the ammeter is installed in line with our circuit element. Doing such, our ammeter is represented by a short circuit. We have current flowing through it, but no voltage drop across it. A voltmeter measures voltage potential and is shown schematically below. Our red lead indicates a positive terminal, and our black lead indicates a negative terminal. In reality, if you have the terminal switched, it is of no consequence, for you will still have the same magnitude of the voltage potential across your element. One main assumption we make when using and employing a voltmeter is we assume its resistance is infinite, such that no current enters our device. Rather, all the current travels through our element, and thus we are able to measure the voltage potential across our element. Our voltmeter is represented as an open circuit device. An open circuit is one where no current passes through, but yet a voltage potential still exists across.